All right, y'all, we're going to talk about binary molecular nomenclature today. And what we've done so far up to this point is we've talked about binary ionic. And with ionic, we had a metal and a nonmetal, or a metal and a polyatomic ion. All right, so we need to switch our thought process today. Okay, so we finished the where the metal kept its name and the nonmetal changed to IDE. And if it was a Roman numeral metal, you had to put the Roman numeral to represent the charge of the metal. You crisscrossed and reduced. Same thing with the metal plus the polyatomic. Okay, if it was a Roman numeral metal, you had to write the charge up here, crisscross and reduce with the polyatomic. Okay, so we've done binary and ternary ionic nomenclature. Okay, but now we're at binary molecular nomenclature, and what that means is now we're going to have two non-metals. So where are the non-metals? They are to the right of the staircase. So we're going to be using two things from the right of the staircase. All right? And the thing about that is, with ionic, there was only one way to write them. It was the law of definite proportions, because you crisscross the charges and the total charge had to be zero. This is not like that. So this follows the law of multiple proportions, which means there's more than one way to write it. Multiple ratios or proportions, either way. I like ratios better. So that means I could have N2P6, or I could have N3P9. There's multiple ways to write the different compounds, and it's because they're sharing electrons. All right, so because there's multiple ways to write it, you can't just put nitrogen phosphide. You have to include how many there are. So for this one, it would be dinitrogen, and it would be hexaphosphide. So as you can see, you're going to put the prefix for how many there is, and those prefixes are the following. Mono is 1, di is 2, tri is 3, tetra, like Tetris, when you clear the board with a Tetris, you get the 4, the long stick comes down, you get 4 things, that's a Tetris. So tetra is 4, penta is 5, hexa is 6, hepta, probably the hardest one to remember, is 7, octa, like an octopus has 8 arms, 8, nona is 9, and deca is 10. So these are my prefixes that I need to know, or you need to know, okay? And so you're going to have a prefix. The name of the first element just keeps its name. Then you're going to have a prefix, and then you're going to have the second non-metal changes to IDE, just like they did in ionic. So for this next one, it's going to be trinitrogen. You keep the whole name, prefix, name, and then it's nona phosphide. All right, nona phosphide. All right, so in every example, you're going to see it's going to be prefix, name of the first element, prefix, name of the second element, change to IDE. All right, so let's do a couple more practices. On your sheet, you can look on number 1. It's AS4O10. So AS4O10. So that is going to be tetra arsenic. So you just keep the name of the, and then it's going to be deca oxide. Now, here's one of the rules that you're going to have to learn. Whenever you're dealing with an oxide or an iodide, you're going to drop the A or O on the prefix. So it's not going to be deca oxide, it's just going to be dec oxide. So I drop that A, so it's dec oxide. All right, so some other ones you might see, like it's not going to be monooxide, it's going to be mon oxide. It would be mon iodide. All right, you would drop that O. Okay, it would not be penta oxide, it's just pent oxide. And it's pentiodide. All right, so whenever I have an oxide or an iodide as the second element, okay, you're going to drop the A or the O on the prefix. All right, that's one of the major rules. Okay, the other rule, all right, drop the A and the O. Okay, the other rule, or I should have gone over this. If you have a tri, you keep it. So if it's I3, that's going to be, we'll say it's, whatever you call it, sulfur 2I3. That's di-sulfur, and it's tri-iodide. So you do double up on the I's, all right? You do double up on the I's if it's triiodide. All right, so that's one major rule. The second major rule is this. You don't need mono on the first element, but you have to have mono on the second. So for this one, it's not monocarbon monoxide or monoxide. It's just carbon monoxide. So you don't need mono, no mono on first element. Okay, so if the first element is a 1, you don't put a mono on it. You just list the name of it. The second one, if it's a 1, has to have mono, or it's wrong. All right, so let's do another example for that. What if I did, let's do N3Cl. Okay, so that is trinitrogen monochloride. Now, notice, if it's not an oxide or an iodide, I have to keep that O there. So it is monochloride, all right? And I had to have the mono on the second one. All right, so just a quick review. Anytime I'm doing these, you're going to have prefix, element, you keep the name, the whole name, and then you're going to have prefix and element change to IDE, just like we did with the binary ionics. So that is your base. And then the two rules you have to remember is if it's an oxide or iodide, you drop the A or O on the prefix, and no mono on first element, but you must have mono on the second. So that really there's only like 3 rules with binary molecular nomenclature. All right? So we're going to do one more example and see how we do. So if I have Bn, it's number 3 on your sheet, that is going to be boron mononitride. All right? Now, if you flip the sheet over, okay, now if it gives me the name, okay, then I have to write the formula. So you look at the first one, it's chlorine monoxide. So chlorine monoxide is just going to be Cl and O. Chlorine monoxide. The second one, oxygen difluoride, is OF2. All right, so these are pretty easy because you just look at the prefix, you look at the element. The next one's dinitrogen monoxide. Dinitrogen monoxide is a 1. And then the fifth one is nitrogen trifluoride. So it's nitrogen and trifluoride is NF3. All right, so hopefully this brings it all together for you, and appreciate it.